Good day, students. Welcome to part 2 of the New York Regents High School exam for geometry. We're going to be going over questions 12 to 20 of the August 2012 release question. Okay. Remember that this document is available on the New York Regents website. All right, let's go ahead and take a look at question number 12. So 12 says, what is an equation of a circle shown on the graph below? So let's go ahead and write down the standard form for the equation of a circle first. It is given by x minus h square plus y minus k square equals r square. Okay. What we need to extract from here is the center given by hk and the radius. Okay. So the center was given by h comma k, and the radius is r. So let's see, how can we find where the center of this graph is? Well, if we um, find, if we draw the diameter of this circle, two perpendicular diameters for this circle, it's going to be easy for us to see where the center is. So if you look at this, you notice that these are the extreme points for the circle. So I'm going to draw the first diameter going up and down, and then the next diameter perpendicular to that goes this way. All right. So by drawing this diameter in this fashion, you notice that we have determined the center of the circle. All right. This is where the center of the circle lies. All right. So what are the coordinates of the center of the circle? So the coordinates of the center of the circle is 1, 2, 3, 4. Going down, so that's -4. And to the left, 1, 2, 3, -3. All right. So our center is -3, comma -4, because the coordinates of this point right here is -3, comma -4. All right. Now let's find the radius. The radius is the distance from the center to the circumference of a circle. So that right there is your radius. So how many units is it? So count for how many units from the center to the extreme, right? So count 1, 2, 3, 4, 5. So the radius r is 5. All right. Okay, now finding the center and the radius is pretty easy, but the place where people make most mistakes is inputting this into the standard equation. Okay, so when you're inputting the center into the standard equation, you take the opposite of this. All right, so it's going to be x, since it's minus 3, is going to be x plus 3, because you have two minuses, x plus 3 square plus y minus 4 is going to be y plus 4, or you take the opposite of the y coordinate of the center, square. All right, and then the radius, you don't double it, you square it, okay? So when you square 5, you're going to get 25, all right? Because 5 squared is 25. So there goes the equation of your circle. So let's see what this result matches. It matches option number 2. All right, let's move on to question 13. As shown in the diagram below, M and N are cut by transversal P. If the measure of angle 1 is 4x plus 14 and measure of angle 2 is 8x plus 10, the lines M and N are parallel when x equals. So if these two lines are parallel, we have a situation where we have two parallel lines cut by a transversal. Alright, whenever you have two parallel lines cut by a transversal, angles that look the same are normally congruent, and angles that do not look the same are supplementary. So for every pair, they're either going to be congruent or supplementary. Well, it has to be one or the other. Alright, so guess what? Look at 1 and 2. You can see that they don't look the same, right? Angle 1 is acute, angle 2 is a reflex angle. Is obtuse. So the question is, so since this is acute and this is reflex, obtuse, they don't look the same, hence they're supplementary. Remember, the pairs, anytime you have parallel lines cut by transversal, every pair is either congruent or supplementary. Okay, let me show you that they're supplementary. Angle 1 is congruent to this angle right here. This angle right here is also the same thing as angle 1. The reason being that these are alternate interior angles, okay? Since angle 1 and angle 2 form a linear pair, guess what? They're supplementary. So this tells me that angle 1 is supplementary with angle 2. Alright, so let's write down an equation. What did I just say? Measure of angle 1 plus measure of angle 2 is supplementary, which means they add up to 180 degrees. Okay? Now we're going to use the corresponding measures to values to solve for what x is. Okay? So for our angle 1, I'm going to replace that with 4x plus 14. That's the measure of angle 1. And the measure of angle 2 is 8x plus 10. Okay? Equals 180. Alright. Now let's solve this equation for x. On the left side, we're going to combine like terms. So I'm going to combine 8x and 4x. 8x plus 4x is 12x. And then positive 14 plus 10 is plus 24 equals 180. And then we subtract, to get x by itself, we just subtract 24 from both sides and divide by 12. So subtract 24 from both sides. We end up with 12x equals, let's see, 10, 6, 7, 5, 156. All right, and then to finish this off, we'll simply divide both sides by 12. Divide by 12, divide by 12, and then you end up with x equals 13 degrees. Or actually, it's not a degree. Yeah, we can say it's a degree. So x equals 13. Okay. So the answer to question number 13 is option 3. All right, let's move on to question 14. It says the angle formed by the radius of a circle and the tangent to that circle has a measure of. Now, this reminds me of one of the theorems for circles and tangent lines. If you have a circle uh, and a radius, a line. Let me draw this again. Let me draw my radius first. Okay, so there goes my radius, and then my circle. Yeah. All right. So this is the thing I was gonna share with you. A line or a segment is parallel, is tangent. A line or a segment is tangent to a circle if and only if the line is perpendicular to the radius. So this line, let me call this uh, line AB. Okay. And then this is the radius. We're going to call the radius CD. And this is circle D. So this line AB is parallel, is tangent to this circle if and only if this line is perpendicular to the radius or the diameter. It doesn't really matter. Okay. So since a line is tangent, so the angle formed by the radius of a circle on a tangent line. So this is our tangent line. If this line is tangent to this circle, it must be perpendicular to the diameter. So what does perpendicularity mean? What does it mean for a line to be perpendicular to another line? It means that the measure of this angle right here is going to be, so the measure of angle DCB is simply 90 degrees. Okay? So guess what? That angle formed by the radius and the tangent line has a measure of 90 degrees. All right? So the tangent line is always perpendicular to the radius and the diameter. At the point, it has to be at the point of tangency, okay? All right, you have to draw the diameter or the radius from the point of tangency. All right, so there you have it. Option number 2 is your answer for question 14. Okay, let's move on to question number 15. In this question, it says that a sphere is inscribed on a cube with edges 6 centimeters. What is the volume of the sphere in terms of pi? So I'm always going to draw the cross section of uh, the, the square and the circle. I mean the cube and the sphere. So let's say this is just the cross section of the cube and the sphere. Okay, the sphere is inscribed in the cube. So the question is, what is the volume of the sphere. All right, so let's see. If what are the dimensions of the cube? We know that the measure from this side to this side is 6 centimeters, right? And also the measure from this side to this side, guess what? It's 6 centimeters also because all the sides of a cube, they measure the same thing. Okay, so 6 centimeters by 6 centimeters, and if we wanted to make it into a cube, it's going to be 6 centimeters deep also. All right, so there you have it. All right, so we asked for the volume of a sphere. The only thing we need for the volume of a sphere, if you look at your reference sheet, the volume of a sphere is 4 thirds pi r cubed. So all I care about is the radius. If I know what the radius is, then I will know what the volume of the sphere is. So this is the radius of the sphere right here. Since the diameter of the sphere is congruent to the side length of the cube, then the radius is going to be half as long, okay? So if you look at my sketch right there, the entire diameter is 6 centimeters, so the radius must be half of that, which is 3, okay? So 3 is just half of the side length. Now, we know what r is. Guess what? We can figure out what the volume of the sphere is. So the volume of the sphere is simply going to be 4 thirds times pi times the radius, which is 3 cubed. Okay? All right, 3 cubed is 3 times 3 times 3, which is 27. So we have 4 thirds times pi times 3 cubed, replace it with 27 over 1. All right, now let's cross reduce. We can reduce across or up, down. 3 goes here once, 3 goes into 27 9 times. Multiply across, 4 times 9 times pi is 36 pi. Okay, 36 pi cubic centimeters is the volume of our sphere. So the answer to option 15 is option 2. All right, let's take a look at question 16. It says scaling triangle ABC is similar to DAF. Which statement is false? So when two triangles are similar, that basically means that corresponding angles are congruent and the corresponding sides in proportion. Okay, so let me go ahead and sketch a scaling triangle for you. Uh-oh, wrong shape. Okay, so let's say we have these two scaling triangles that are similar. So if triangle ABC is similar to DF, you notice that you have to be really careful with the direction of the letters. Okay, so I went counterclockwise ABC, so DEF has to go counterclockwise too. Okay, if these two triangles are similar, that means corresponding angles are congruent. This angle must be congruent to that angle. Okay, angle B has to be congruent to angle E, and angle C has to be congruent to angle F. Corresponding angles are congruent and corresponding sides in proportion. So this side divided by this side is going to be equal to this side right here divided by that side. And it's going to be equal to this side divided by this side. Okay? So if I set any two corresponding sides, divide them by each other, I'm going to get the same result as dividing another pair of corresponding sides. Okay? All right, so let's see which is true. The first one says the ratio of AB to BC. So AB to BC, I'm going to write it as a fraction. AB over BC. So I took this side, side 1 and side 3 of my small triangle. I put side 1 as a denominator, as a numerator, and side B as a denominator. So on the second triangle, I have to follow the same pattern in creating a ratio with the corresponding sides. So this side is corresponding with that side. So since this is the numerator, DE has to be the numerator on the other side, on the other ratio. And since this was the denominator, side 3, so side 3 also has to be the denominator on the bigger one, okay? So you see how when you're forming the fractions, they have to match. Numerator, denominator, numerator, denominator, okay? So AB over BC is proportional to DE over EF. Correct. Let's take a look at the second one. AC over DF is equal to BC over EF. Okay, so AC AC is side 2 on the small triangle over DF. DF is side 2 on the big triangle. Okay, so since I did side 2 on the small triangle divided by side 2 on the big triangle, then I have to match it with side 1 over side 1 big and small, or side 3 over side 3 big and small. Okay, all right, so BC is side 3 on the small one, so I better pick side 3 on the big one over there. Okay, so AC over DF is equal to BC over EF. And if you wanted to extend it, they didn't ask us, but we can do that also. It's also equal to AB over BE. Okay, so in this ratio that we're setting up a ratio of corresponding sides. Okay, so side 2 over side 2 is equal to side 1 over side 1 is equal to side 3 over side 3. Okay, so AC over DF is equal to BC over EF. Absolutely, option 2 is correct. Now, next step is 3. It says angle ACB is congruent to angle DEF. ACB, this angle right here, is congruent to DFE. Absolutely. They're corresponding angles, so they have to be congruent. Angle ABC, which is this double angle right here, is congruent to angle EDF. EDF is angle 1 here. They're not congruent. This angle right here is not congruent to that angle. This angle is congruent to that. Okay, so this is wrong. So the statement that is false is statement number 4. All right? Okay. Now we right along to question number 17. It says, which equation represents a line that is parallel to the line whose equation is y equals 3 over 2x minus 3 and passes through the point 1, 2. All right, so we have two lines, let's say L1 and L2. If L1 is parallel to L2, then the slope of L1 will be equal to the slope of L2. Okay, so let's say this is L1, right? Now, what is the slope of the second line going to be? So let's take a look at this equation, y equals 3 over 2x minus 3. How do I know the slope on the y-intercept? Well, I know the equation y equals mx plus b. Okay, so the coefficient of x is your slope. All right, so from this line, I can clearly see that my slope is 3 over 2. Okay, so m equals 3 over 2. Now this is the slope of the other line. What is the y-intercept of the other line, so I can write down the equation? Well, I don't know. We're told that we have a slope of 3, 2, and it goes through 0.12. Okay, I'm going to call this x1, y1. Now to write out the equation of the second one, I'm going to show you two methods of doing this. Whichever one you like, you can use. Okay, method 1 involves using the point slope equation, y minus y1 equals mx minus x1. Okay, all right, let's go ahead and do that. So we're going to have y minus y1, y1 is 2, equals m, which is 3 over 2, x minus x1, which is 1. Okay, all right, so what we're going to do here to put this in a point slope form, we need to distribute this 3 over 2 to both. So we have y minus 2 equals 3 over 2x minus 3 over 2. And then we add 2 to both sides to get y by itself. So we add 2 and add 2. Okay, this add out to 0. So we have y equals 3 over 2x minus 3 over 2 plus 2. Let's write 2 as a fraction, okay? So what we'll do next is find the numerator and find the LCD. So you times this by 2 top and bottom. And then that yields y equals 3 over 2x minus 3 over 2 plus 4 over 2. Final answer is y equals 3 over 2x plus 1 half. Okay, so there goes the answer. So the answer is option number 1. Okay, so that's method 1 using the point slope form. So let me show you another method of doing this. This requires the use of the slope intercept form. Method 2, we're going to use y equals mx plus b. Okay? Now, we know m, all we need is b, and then we're going to plug it back into this y equals mx plus b equation. We're going to use it twice in this method, okay? So first thing we're going to do is find b. So to find b, we're going to set x and y to x1, y1, okay? So we're going to write down the equation. So instead of y equals mx plus b, we're going to write, instead of y, I'm going to use 2. Let me write this again so you don't get confused. Y equals mx plus b. So y is going to be 2 and x is going to be 1. All right, so 2 equals, m is 3 over 2, we already know that. X is 1 plus b. Okay, so we're going to have y equals 2 equals 3 over 2 plus b. Now to get b by itself, we just subtract 3 halves from both sides. Okay, so subtract 3 over 2, subtract 3 over 2. So we have b equals 2 minus 3 over 2. Express 2 as a fraction. Find the LCD, which is 2, so times this by 2 top and bottom. So we have b equals 4 over 2 minus 3 over 2, which equals 1 over 2. Okay, so now I know my b and I know my m. I already knew my m before, so my equation is going to be y equals m x plus b. All right, so there goes your answer. So whichever method you like, you can go ahead and use. All right, so the answer is option 1. Now let's take a look at question 18. It says line A and B intersect at a point P. Line C passes through P and is perpendicular to the plane containing lines A and B. Which statement is true? All right, so let's draw lines A and B first. So we have line A and line B. We know that they intersect. That's basically all we know. They intersect at a point P. Okay. So this is line A, and this is line B, and they intersect at a point P. All right. And then you're told that line C passes through P and is perpendicular to the plane containing lines A and B. So what we're gonna do now, let's go ahead and draw ourselves a plane containing lines A and B. All right. So, oops. Okay. Okay, so there we go. We have a plane containing line A and B, but C is perpendicular to this plane and goes through this point. So if C is perpendicular to this plane and goes through this point, then this is what C is going to look like. It's going to look something like this. Okay? So guess what? If C is perpendicular to this point, if C is perpendicular to this plane, then any line that lies in this plane is also going to be perpendicular to C. All right, so guess what? C is going to be perpendicular to A. That in green. C is going to be perpendicular to A, 90 degrees. And if you rotate, C is also going to be perpendicular to B. Whichever way you look at it, C is always going to be perpendicular to any line that is contained on this plane. Okay, any line on this plane, C is going to be perpendicular to it because C is perpendicular to this plane. And this plane is basically a collection of all the lines that lie on it. All right, so there goes the sketch. So let's see which is true. Option 1, A, B, C are coplanar. Absolutely not. C is not contained in this plane. Only A and B are coplanar, so this is false. A is perpendicular to line B. Where did that come from? You're not told anything about line A and B. You're just told that they intersect and they are coplanar, right? Because there's a plane that contains A and B. So they are intersecting and coplanar. That's all you know about A and B. There's no statement about perpendicularity, so that's false. Line C is perpendicular to both line A and B. Absolutely, because line A and B both lie on the plane perfectly. So since C is perpendicular to the plane, C has to be perpendicular to any line that's contained on that plane. All right, so this is correct. And then this line C is perpendicular to line A or B, but not both. This is false. Since they're on the same plane, they are parallel, right? So if C is parallel to perpendicular to A, it must be. I mean, I don't mean they're parallel. I'm sorry. Since they are on the same plane, then they're gonna have the same. They're gonna be coplanar, all right? And since C is perpendicular to that, from that perspective, from C's perspective, they have the same steepness. So C is perpendicular to both of them. So this is false also. All right. So the correct answer is option 3. All right, let's take a look at 19. It says, as shown in the diagram of triangle ABCD below, ACD below, B is a point on on a segment on AC, as shown here, and on AC and DB is drawn. Okay, so this point is drawn here. If angle A is 66, CDB is 18, and measure of angle C is 24, what is the longest side of triangle ABC? So for this, all right, so let's see. In triangle ADB, we're just focusing on this triangle right here, triangle ADB. It says, what is the longest side? Now, what determines the longest side of the triangle? Well, the longest side is always opposite the biggest angle. So if we can determine the value of all these three angles and compare them, whichever one is the biggest, the side opposite that angle will be the biggest. So if this is the biggest angle, then this side DB will be the longest side. If angle D is the biggest angle, the opposite side AB will be the longest, and if side B, if angle B is the biggest angle, then side AB will be the longest side, okay? All right, so the task now is to find the measures of all the three angles. So let's go ahead and do it. Taking a look at triangle DBC, we know using the triangle angle sum theorem that the sum of angles in a triangle is 180. So how do we find the measure of this angle right here? Since they all add up to 180, we can simply find this angle right here by subtracting the sum of these two from 180. So 180 minus 18 plus 24. Okay, 180 minus 18 plus 24 will give me the measure of this angle in triangle DBC. So we add these two angles together. We're going to have 180 minus 18 plus 24 is 42. So we have minus 42. And then 180 minus 42 is equal to 138. Okay? So this angle right here is 138. All right. What we care about is the interior angles of these angles right here. So what I'm trying to do is if I can find this, then I can determine what this angle is. How do I do that? Well, these two angles form a linear pair, which add up to 180. They're supplementary, okay? So this is 138. Then what is the measure of this angle going to be? It's simply going to be 180 minus 138, since these two angles are a linear pair, all right? If I subtract it, I'll get 42. So this angle right here is 42. So we know that this side is longer than this side because this angle is bigger than this angle. But we have to find this one, right? So let's go ahead and find this. What is the measure of this angle right here? Well, we're going to use the triangle angle sum theorem again. We know the sum of these three angles is 180. So if I know these two, I can subtract their sum from 180 to find that angle, right? So that one is simply 180 minus the sum of these other two angles, 66 plus 42. Okay, so that's 180 minus, if I add these two together, I get 108. 180 minus 108. If we subtract this, we'll get 72 degrees. Okay, all right, so this angle right here is 72 degrees. So which side is the longest? Since this is the biggest angle, this is the longest side, okay? And then followed by this side because 66 is next, and this is the shortest side. So segment AB is the longest segment in this triangle, or this side AB is the longest side, all right? So the answer is option number 1. All right, let's take a look at the last one. Oh, wait. Yeah, there you go. All right, so it says in triangle ABC, shown below, P is a centroid and BF is 18. What is the length of BP? So we're going to basically use the triangle centroid theorem. If you have a triangle of this nature and P is a centroid, then we have a set of equations. We can write down three equations. Uh, it turns out that the longer side of the segment that is being partitioned by the centroid is always 2/3 of the entire length, okay? So we have all these medians right here. This median right here, this longer portion of the median is always 2/3 of the entire median, okay? Same story here. The longer side of the median, AE, is going to be 2/3 of the entire median, and then the same story here, okay? So let's write down the equations. So for BF, the entire median BF is going to, actually BP is equal to 2/3. It's 2/3 of the entire median. So 2/3 of BF. Okay. And then let's look at the next one. AP, which is the longer section of this divided segment that's broken apart by the centroid. AP is equal to 2/3 of the entire median AF, AE. Okay. And then for median ACE, for median CD, partitioned by P, the point of concurrency of the three medians, which is a centroid, we have CD equals, I'm sorry, CP, which is the longest side. I keep indicating the whole thing. So CP, which is the longer portion of the median separated by the centroid, equals 2/3 of the entire median, which is CD. All right, so this is the centroid theorem for triangles. All right, so in this case, we're dealing with BF and BP. Okay, so BP is the longer side, right? So the longer side of the segment broken, the longest, the longer side of the median broken apart by the median, the longer side of the median broken apart by the centroid is basically 2/3 of the entire median. All right, so we're using this equation right here. Okay, so let's go ahead and write it again. BP, longer side of the median, is equal to 2/3 of the entire median. Okay. All right, so we know that BP is what we're looking for. We don't know what that is. So let's take those lines out of there. So BP equals 2/3 of BF, which is 18. Okay, and just do the basic arithmetic and we'll be good. So BP equals 2 times 18 is 36. 36 over 3 equals 12. All right, so BP is 12 units long. All right, so there you have it. All right, so thanks so much for taking the time to watch this video. You can feel free to subscribe to my channel by clicking up here. If you like this video, you can click like down here. And please, please, please post a comment and tell me what you think about this video. More clips can be found on Mathgotserved.com. Thanks again and have a wonderful day.